this problem we are going to solve a simple static analysis. So first we need to create the geometry. I will start by defining a solid block with dimensions 0.1 meters by 0.1 meters for the base and a height of 1 meter. Once the brick is ready, I will split this surface at a distance of 0.1 meter. I created a split because I want to apply pressure specifically on this surface. Next, I will move to the meshing step. Here I will directly select the volume mesh and I will set the mesh size to 0.01 and choose the submap method for a structured mesh. Next step is to assign the material. In this case we are using wood as the material, so I will input Young's modulus as 8e plus 0.9 and Poisson ratio to 0.3. Let's move on to the boundary conditions. Here I will apply a pressure of 30,000 Pascal to the top surface and then I will fix this end surface to restrict any movement. After that I will go to calculation settings and select static analysis along with elasticity. I will run the simulation to determine the stress and deformation in the structure. Finally, to solve any analysis, these are the 5 steps we need to perform here, and these are some of the options throughout the process. Once everything is set up, we will run the analysis and last step will be to view the results in the FIDESYS viewer. Next, we will delve into the next step into FIDESYS software. From the command panel, select manage geometry, manage volumes, create volumes, and from this list select brick, enter brick dimensions, x width 0.1, height 1, click apply. Second step is to create split. Go to manage curves, create curves, select line. By holding Ctrl key, select these two vertices, then click apply. You can see here a curve is created successfully. Next step, we need to transform this curve at a distance of 0.1. So select transform curves, select move, then select this curve. Make sure you will select this curve, so enter the curve ID 13. We need to transform this curve in the y direction, so enter 0.1, then click apply. Now to split this surface, select manage surfaces, then modify surface, then from the list select split and select the surface, select these two vertices, then click apply. Now you can see here two surfaces were created. Next step is to generate the mesh. Go to manage mesh, manage volumes, define intervals and sizes, choose appropriate size. I'll select this volume, then enter the size 0.01, then click on apply size. Next click on specify meshing schemes. From this list select submap, then click to generate mesh. Now the mesh is generated. Now we need to assign the material to this brick. So go to this manage materials, create. So here, from here you can simply drag and drop it here to create a material, or you can simply create your own material. So I'll enter name as wood. So from the left I'll select and drag material properties. So I'll set the Young's modulus to 8e plus 0.9 and Poisson's ratio to 0.3 and then click apply. So once we create the material, we need to create block to assign the material. So click on manage blocks and then click on add. So we will create block. So select this volume and create a block. Now we need to assign the material to this block. So select the block ID, then select the material, then click apply. Next step, we need to apply boundary conditions. So select boundary conditions, select displacement. So here I will fix this end. So select surface, then select this entity. I want to fix in all directions, so select all, set the degrees of value to 0, then click apply. The next step is to apply pressure. So select pressure, so select this surface. I'll apply a pressure of 30,000 Pascal, then click apply. You can also check the boundary conditions in the properties page. So click on loads, pressure. If I click here, you can check it out here. The last step is to solve the problem. Go to calculation settings, select static calculation, general settings, choose elasticity and click apply. So save the file before starting the calculation. Now save the file. Once the calculation is finished, click on the results to open the viewer. So this will give you access to post-processing tools, so where you can analyze the outcomes. In the viewer, you can check both displacement and stress. Now select warp by vector to visualize deformation, then adjust the scale and then click apply. Now I'll just rotate this. Now you can see here the fixed end will have 0 deformation, while the maximum deformation occurs where the pressure was applied. Now if I select stress, so the stress is highest at this fixed end. Now if I select the hover points on, you can check the stress here.